Jai Hind students, welcome to my YouTube channel. Students, carrying a load of anger wastes your energy. It blocks communication. So never ever say any mean things to others even if you feel like doing so. Always be cheerful. Always be lovable. Always say kind words to others. Pay due respect to your elders and love your youngsters. So students, what I mean is, just develop these basic qualities of human being. Be humane in nature, right? And as I've told you, as per the law of nature, whatever you give to the society, whatever you give to your surroundings, to your surrounding people, the same thing will definitely return in your life. So, basic thing is spread happiness, right? So let's start this session. We are going to discuss a very important topic of upthrust and the concept of buoyancy. So I will introduce this term of upthrust by considering few examples. Now, you must have noted down upthrust. It is made up of two words, up and thrust. Up means upward. Thrust we have discussed in detail in the previous lecture. Thrust is a force acting on a surface normally, that is in a perpendicular direction. So upward force is known as upthrust, right? So how to introduce this topic? In order to introduce this topic, let us consider a very basic example which we all have observed in our daily life. So let's start with this example. Suppose this is a bucket or a water tank, and let us consider a sealed empty can, a sealed empty steel can to be immersed inside this tank containing water. This is a sealed can. It is a sealed steel can. Sealed, closed steel can. And suppose it is immersed in water. Now what happens is, students, as we try to push the steel can into the water, inside the water, then we will experience an opposing force. We will experience an upward force. We will apply a force on the can in the downward direction so as to immerse it deeper into water, but at the same time we will experience an upward force. The more we try to immerse this can inside the water, the more is the upward force which we will experience. So that upward force exerted by the liquid on this can, on this body in the upward direction, that is known as upthrust. Actually, upthrust is also known as buoyant force. So what happens is, you can do it in your practical life as well. Suppose this can, and if you immerse it completely inside the liquid and just release it, then what happens? Immediately, instantly, the can will come on the surface of the water. It is because of that upward force exerted by the liquid on the can. So this force exerted by the liquid on the can in the upward direction, it is known as upthrust. This force is known as upthrust, or it is also known as buoyant force. Clear, students? Let us consider second example. Again, let us consider a water tank, and let's consider the tank to be filled with water, and a cork is considered to be floating on the surface of the water like this. This is a cork. Suppose this is a cork. It floats on the surface of the water. Now here also if you try to push the cork inwards, if you try to immerse the cork deeper into the water, then what happens? We'll experience an upward force. We'll feel that force. And if it happens that we release the cork inside the water, then the cork will immediately come on the surface and again start floating on the surface of the water. So, students, that upward force which this liquid exerts on the body, that is upthrust. So, this force I am talking about is upthrust. And as I told you, upthrust is also known as buoyant force. It is also known as buoyant force. I will denote this buoyant force with FB. F stands for force and B stands for buoyant force. Or buoyant force may also be denoted by U. U is the upthrust. So I will denote upthrust or buoyant force by capital letter U or FB. So how do you define buoyant force then? Whenever a body is partially or completely immersed in a liquid, then the liquid exerts on the body an upward force. That upward force is known as the buoyant force. So I will write down the definition. So buoyant or upthrust, buoyant force. How do you define it? It is an upward force exerted by liquid, or if you generalize it, or fluid. Liquid or gas, both exerts upward force on a body which is immersed on it. So buoyant force is an upward force exerted by liquid on a body when the body is partially or completely immersed in the liquid. So this is the actual definition of buoyant force or upthrust. Upthrust, remember, upward thrust is the force acting on the surface normally. So upward force exerted by a liquid or gas or a fluid on the body when it is partially or completely immersed in that fluid. That is known as buoyant force or upthrust. It is a force. So its SI unit is Newton. Right? So this is about buoyant force. Now students, we will discuss how the buoyant force and why the buoyant force acts on a body. What is the basic reason for the origin of this buoyant force? For that, again, we need to consider a very, very important theoretical consideration. In the previous lecture, we have discussed about pressure. So, we will see that buoyancy is actually due to the difference in the pressure on the two surfaces of a body. That is what we are going to discuss. So till now we have discussed upthrust, buoyant force, and the property of a fluid by virtue of which it exerts an upward force on a body is known as buoyancy. So buoyancy is the property of a fluid by virtue of which it exerts an upward force on the body which is partially or completely immersed in it. So that property of the fluid is known as buoyancy. Now, cause of buoyant force. Cause of buoyant force. So this we need to discuss. For this, students, very, very basic points to be noted is that, so students, these are the two very, very important points to consider while discussing the cause of buoyant force. The first point, a liquid contained in a vessel exerts pressure at all the points and in all the directions. What I mean to say is that, students, let us consider my case. I am surrounded with air. Air is a fluid, it's a gas, so it is a fluid. So, air is exerting pressure on my body in all the directions, right? And most importantly, it exerts pressure at all the points. At every point on my body, air is exerting pressure, and in all the directions. Suppose this is a body and air is exerting pressure in all the directions. This is a particular point. So air is exerting pressure at this point, along this direction, along this direction. In any direction it can exert pressure. So basically a liquid or a fluid, in case of, instead of writing liquid, you can write fluid. It is applicable for both liquid as well as gas. A fluid contained in a vessel will exert pressure at all the points. That is, if this is a vessel and this is the liquid, so the liquid will exert pressure at all the points, right? It will exert pressure at all the points, no doubt regarding this. This we have already discussed in the previous lecture. Pressure actually is thrust per unit area. Thrust is the force exerted by the liquid on the surface normally. So definitely it will exert pressure at all the points and in all the directions. I hope now it's pretty clear, right? Second point, the pressure at a point is same in all the directions. At a point, suppose this is point A. At this point, the pressure either upward or downward or towards right or towards left, at a particular point, the pressure will be constant. So, the pressure at a point is constant or same in all the directions. In all the directions, whether we are considering upward, downward. So, if you are considering this point, so here the pressure in the upward direction or the pressure in the downward direction or the pressure towards right or the pressure towards left, all are same. The pressure at a point is same in all the directions. Clear, students? And the most important thing is, it increases with the depth inside the liquid or inside the fluid. So let me try to condense the last point. It increases with the depth inside the liquid. Now suppose, students, let us consider this to be the water surface and this is a mountain and this is a sea or a river. Now this is Earth's atmosphere. This is suppose sea and this is sea level. It is at some height and this is at some depth. Suppose this is point A, this is point B, and let us consider this to be point C, right? So at point A, students, at point A, the pressure would be due to the weight of the atmosphere above this line, this imagined line, isn't it? Pressure is thrust per unit area. Thrust is force. Force here would be equivalent to the weight of the atmosphere above this imagined line. So it would be thrust, which is the weight of the atmosphere above this imagined line, divided by per unit area. That would be the pressure at point A. While the pressure at point B would be equal to the weight of the entire atmosphere above the sea level. So obviously here the weight of the atmosphere would be much more. Accordingly, the pressure at the sea level would be much more as compared to the pressure at some altitude. So PB is greater than PA. Now what about point C, students? At any point on the sea level, the pressure is due to the Earth's atmosphere. And inside the liquid, at point C, the net pressure would be due to the atmospheric pressure plus the pressure exerted by this height of the liquid column. So as the depth is increased inside the liquid, the atmospheric pressure would be constant, but the pressure exerted by the liquid will keep on increasing because the weight of this liquid column will keep on increasing with the increase in the depth inside the liquid. So, pressure at point C would be greater than the pressure at point B, and it is greater than the pressure at point A. So what I mean to say is that, students, as we go up, as we gain altitude, the atmospheric pressure decreases, right? At the sea level, it is 1.013 into 10 raised to the power 5 Pascal. This we have discussed. 1 atm, 1 atmospheric pressure, it is 1.013 into 10 raised to the power 5 Pascal. And as we go deeper inside the sea, the atmospheric pressure increases. So inside the liquid, the atmospheric pressure increases with the increase in the depth. So this is a very, very important concept. Now coming to the cause of buoyant force or the cause of upthrust. For that, let's consider this example. This is suppose a water tank, and this is a body, maybe a cubical body. And this area is A, suppose. And it is completely immersed inside the liquid. Completely immersed. Now look, students. On the walls of the body, the pressure acting or exerted by the liquid would be equal and opposite. The magnitude of the pressure at this point would be equal to the magnitude of the pressure at this point. So this being equal and opposite, they will tend to cancel out. And still, when the depth is increased, the pressure will also increase. But this being on the same line below the free surface, the magnitude of the pressure in both the cases would be same, but again being opposite directed, it will get cancelled out. Here, the pressure would be somewhat less because the distance of this point below the free surface of the liquid is much smaller as compared to the other point. So, consider the length of the arrows. Length of the arrow suggests the magnitude of the pressure or magnitude of the force exerted by the liquid on the body. So these forces which are acting on the walls of the body, and these are the forces which are exerted by the liquid on the walls of the body, being equal in magnitude and oppositely directed, they will tend to get cancelled out in pairs. This is regarding the walls of the four walls of the cubical body, right? Now consider the top and the bottom face. This face, suppose it is 1, and let us consider this face, it is 2. Now these two faces are at different depths from this free surface of the liquid, right? It is at smaller depth and face 2 is at larger depth inside the liquid. So at point A, which is, or rather on the bottom face, the pressure exerted by the liquid would be large because the pressure increases with the increase in the depth inside the liquid. That is what we have discussed, right? So here the pressure is much larger. Suppose it is P2. And here on the top face, the pressure is smaller. So these two are oppositely directed, but since they are of unequal magnitude, therefore they won't cancel out the effect of each other. Understood, students? These two faces will exert, or rather the liquid will exert on the top and bottom face different force or different pressure. It is because of the fact that these two faces lie at different depths inside the liquid. More the depth, more is the pressure. Lesser the depth inside the liquid, less will be the pressure. And pressure is thrust per unit area. Thrust always acts normally to the surface, that is perpendicular to the surface, right? That is what I have indicated with this diagram. So here obviously P2 is greater than P1. Clear, students? So net force, or rather force on face 2, suppose it is F2. Force acting on face 1, suppose it is F1. So obviously, as we are aware, pressure is force per unit area. So force would be pressure multiplied by area. So F2, it would be equal to P2 into A. A is the area of the bottom and the top face of the body under consideration. Similarly, F1 would be P1 into A. Since P2 is greater than P1, therefore F2 would be greater than F1, and hence F2 is greater than F1. Both are acting in the opposite direction. Suppose this is 1 Newton acting downward and this is 3 Newton acting upward. So net force acting on the body would be 3 minus 1, that is 2 Newton in the upward direction. So students, net force exerted by the liquid on the body, it would be equal to F2 minus F1, which is equal to, if we substitute this value, it would be P2 minus P1 into A. And F2 being greater than F1, net force will be directed in the upward direction. So this net upward force exerted by the liquid on the body when it is immersed inside the liquid is known as upthrust. It is known as buoyant force. And this property which is exhibited by the liquid is known as buoyancy. Clear, students? So this was a very, very important concept. So what is the cause of buoyant force then? Buoyant force is due to the difference in the pressure on the top and the bottom faces of the body when it is immersed inside the liquid. Again I repeat, students, buoyant force or upthrust or the buoyant force exists, or it comes into play due to the difference in the pressure on the top and the bottom face of a body when it is immersed inside a liquid. So due to this pressure difference, a net upward force acts on the body in the upward direction. This upward force exerted by the liquid on the body is known as buoyant force. Clear? Now let us consider the magnitude of the buoyant force. How to measure the buoyant force? So there is a mathematical verification of it, but I will restrict myself to only the theoretical part. So students, the buoyant force, it is actually the upthrust and it is equal to, remember this formula, upthrust or buoyant force. It is actually equal to, I am writing it over here, weight of the liquid displaced by the submerged portion of the body. So definitely, students, we can take a graduated cylinder like this. This is a graduated cylinder, right? A scale is provided over here, and suppose a liquid is poured over here. Now when you put a stone into this container, what happens? The stone will sink and the level of the water will rise. Suppose this was the initial level of water, and after dropping this stone inside the liquid, the level of water is now at B. So this is the volume of the liquid displaced, and this volume of the liquid would be exactly equal to the volume of the body, which is completely immersed inside the liquid. Clear, students? And it is found that the upthrust is equal to the weight of this displaced liquid. So, weight we are aware of this formula. Weight is M into G, right? So, weight would be equal to mass of the liquid displaced, weight is m into g multiplied by acceleration due to gravity. Clear, students? Now mass of the liquid displaced, it will be equal to mass is volume into density. This we are aware. Mass is volume multiplied by density. So mass of the liquid displaced would be equal to volume of the liquid displaced multiplied by density of the liquid displaced. Multiplied by acceleration due to gravity. Now here you can experimentally verify that the volume of this body, which is completely immersed inside the liquid, it is exactly equal to the volume of this displaced liquid. So in place of volume of the displaced liquid, you can write volume of the body. Volume of the body, which is completely submerged, multiplied by density of the liquid multiplied by small v. So this is the formula for buoyant force or upthrust. We will discuss about this in the next section or next session as well, right? So anyway, I must repeat this topic. We'll do some numericals based on it, where I'll be again clearing your theoretical concepts. So students, upthrust, we have just now discussed the cause of upthrust. It's due to the pressure difference on the top and the bottom face of a body which is immersed inside the liquid. Upthrust is actually the weight of the liquid that get displaced when a body is immersed in the liquid. Here, before putting this stone inside this beaker, the level of the water is at point A. Now as we immerse this stone, it completely sinks and the level of water is raised. It can be experimentally verified that the volume of the stone is exactly equal to the volume of the water displaced, and the upthrust, which is the weight of the, which is the force exerted by the liquid on this body, is found to be exactly equal to the weight of this displaced liquid. And weight of the displaced liquid would be equal to the mass of the displaced liquid multiplied by acceleration due to gravity. Mass of the displaced liquid would be equal to the volume of the displaced liquid multiplied by density of the liquid. Now since the volume of the displaced liquid is exactly equal to the volume of the body which is completely immersed inside the liquid, therefore in place of volume of the liquid displaced, you can write volume of the body which is completely immersed. So this becomes the formula for the upthrust. Upthrust is the weight of the liquid displaced by the submerged portion of the body. Clear, students? Okay, what we'll do is we'll discuss some numericals based on buoyant force. That will make the concepts that much more clear, right? Okay, let's proceed with some numericals then. Okay, students, now let us consider some numericals based on the concept of upthrust and buoyancy. Right, students? Okay, let's concentrate on the first question then. First question, students. A cubical block is given and it is given to be completely dipped inside water. Each edge of the block is 1 centimeter in length. We are supposed to find out the buoyant force, right? So, this is the scenario basically. This is a block, this is a cubical block, and each is of 1 centimeter. And it is completely immersed inside liquid, right? So we are supposed to find out the buoyant force. Students, buoyant force, as we have studied, it is also known as upthrust, upward force. It is given by the weight of the liquid displaced by the body. displaced by the submerged portion of the body. Okay students, this is the formula for the upthrust or the buoyant force, which is the weight of the liquid in which the body is immersed, displaced by the submerged portion of the body, right? Now weight, what is the formula for the weight? It will be equal to mass into G, right? It is equal to mass of the displaced liquid, mass of the displaced liquid multiplied by acceleration due to gravity, that is small g, isn't it? Weight W is equal to mg, nothing new here. Now what is the mass of the displaced liquid? Mass of the displaced liquid is equal to volume of the liquid multiplied by density of the liquid. Mass is volume multiplied by density. So mass of the displaced liquid is volume of the displaced liquid multiplied by density of the liquid which is displaced multiplied by acceleration due to gravity. So mass is equal to volume into density. Now students, we are aware when this block is immersed into water, then the same volume of water which is equal to the volume of the block itself will get displaced. So volume of the liquid displaced would be equal to the volume of the body which is immersed inside the liquid. So this is the volume of the displaced liquid. It would be equal to the volume of the body because the entire body is immersed. So in place of volume of the displaced liquid, you can write volume of the body multiplied by density of the liquid multiplied by G, right? So volume of the body, it is given to be a cubical body of dimensions 1 into 1 into 1. So volume would be length into breadth into height. It's given in centimeters, so it will be centimeter cube. So in order to convert it in SI, we have to write 1 centimeter as 10 to the minus 2 meter. So that will give us 10 to the power minus 6 meter cube, right? So the volume of this body, which is equal to the volume of the displaced liquid, it will be equal to 10 raised to the power minus 6 meter cube. Density of the liquid, here the liquid is water and density of water is 1000, that is 10 to the 3 in SI, that is kg per meter cube. And students, acceleration due to gravity, its value can be considered to be 10 instead of 9.8. Just to make the calculation simpler, let's consider 10 meter per second square. Now look, meter cube per meter cube get cancelled, isn't it? So we are left with 10 to the minus 6 into 10 to the 3 into 10. So that will give us 10 to the minus 2 kg meter per second square. Kg meter per second square. This is mass and this is acceleration. And it is Newton. So 10 to the minus 2 is 0.01 Newton. Kg meter per second square is Newton. So this is the upthrust or this is the buoyant force. I hope you have understood this concept, students, right? So we are over with question number 1. Let's discuss question number 2 then. A body of mass 2 kg and density 8000 kg per meter cube is completely dipped in a liquid of density 800 kg per meter cube. Find the force of buoyancy on it. So we are supposed to make use of the same formula, right? So buoyant force, as we are aware, it is also known as upthrust, upward force, and it is equal to the weight of the liquid displaced by the submerged portion of the body. So weight of the liquid would be mass of the liquid multiplied by acceleration due to gravity. Weight is equal to m into g. Mass of the displaced liquid would be volume of the displaced liquid multiplied by density of the displaced liquid. And students, volume of the displaced liquid would be exactly equal to the volume of the submerged portion of the body. Clear? So let's try to solve it then. We have to make use of the same formula. So in question number 2 again, we are supposed to find out the upthrust. So what we do is, let's write down the given information. Question number 2, right? Mass of the body is given. Mass of the body is given to be 2 kg and density of the body is given to be 8000 kg per meter cube. So we can easily find out the volume of the body. So volume of the body would be equal to what? Mass is volume into density. So volume would be equal to mass over density. It is mass divided by density of the body. So what is mass? 2 kg. What is density? It is 8000. So volume in SI would be in meter cube. Clear, students? This is the volume of the body under consideration and it is completely immersed. So this volume of the liquid will get displaced. So we are supposed to find out the force of buoyancy. So force of buoyancy is volume of the body multiplied by density of the liquid multiplied by small g. Why we have considered volume of the body? Because volume of the body would be exactly equal to the volume of the displaced liquid. So volume of the body is 2 by 8000. Let's write the unit as well. It is meter cube. Volume would be in meter cube. Okay, density of the liquid. Remember, it's the density of the liquid. Density of the liquid is 800. It is kg per meter cube. And as I have suggested, in order to make the calculation simple, we can consider the value of acceleration due to gravity. That is small g as 10 meter per second square, right? So consider 10 meter per second square. So what we get is 800, 800 and this 0 get cancelled. So we get 2 kg meter per second square. Per meter cube get cancelled. And kg meter per second square. Kg is the unit of mass, students. Meter per second square is the unit of acceleration. M into A, that's force. So it is actually Newton. This is actually Newton. So it is 2 Newton. So students, in the second case, the force of buoyancy, that is the upward force acting on the body, is 2 Newton. Right? Okay. Let's concentrate on the next question. Third one. Third question is pretty important and interesting one. A piece of iron of density 7.8 into 10 to the minus 3 kg per meter cube and volume 100 centimeter cube is totally immersed in water. Actually, density of iron should be 7.8 into 10 to the plus 3. It should be 7.8 into 10 to the plus 3, right? Kg per meter cube and volume of this much value is totally immersed in water. We are supposed to find out the calculate of the iron piece in air, the upthrust and the apparent weight in water, right? So let's consider first case then. So what we do is, let's find out the weight of the iron piece in air, that is the actual weight. Weight of iron piece in air. It will be the actual weight. The formula is m into g. Let us consider it to be W1. Weight is equal to mass into acceleration due to gravity, right? Mass. What is the mass? It is volume into density into g. Mass is equal to volume into density. So the actual weight of the body would be equal to volume is given to be 100 centimeter cube. 100, don't forget to convert centimeter cube into meter cube. 1 centimeter cube, it would be equal to 10 to the power minus 6 meter cube. So into 10 to the minus 6 meter cube. This will be the volume of the body. This is the volume of the body. This is the density of the body and this is the acceleration due to gravity. Multiplied by density of the body. Density of the body is 7.8 into 10 raised to the power 3. Acceleration due to gravity considered to be 10, right? So W1, it would be equal to, let's see, 10 raised to 3, this 10 raised to 4 and these 2. So 10 raised to power 6 and 10 raised to minus 6 get cancelled. So we'll be left with only 7.8 Newton. So this is the answer of the first part. It is the weight of the iron piece in air, right? Now let's find out the upthrust. Let us denote it by U, upthrust. It is the upward force, right? And this is equal to the weight of the liquid displaced by the submerged portion of the body. So in this case, students, it would be V, volume of the body. Why we are considering the volume of the body? Because volume of the liquid displaced would be exactly equal to the volume of the body which is completely immersed in the liquid. Multiplied by, here density of the body, here we will write density of the liquid multiplied by G. So as we have discussed in the first two questions, upthrust is weight of the liquid displaced by the submerged portion of the body. Here the entire body is immersed in the liquid. So the volume of the entire body would be equal to the volume of the liquid displaced, right? So in place of volume of the liquid displaced, you can write volume of the body. So volume of the body or volume of the liquid displaced multiplied by density of the liquid, it will be mass of the liquid displaced. When it multiplied by G, it will give us weight of the liquid displaced. So upthrust is weight of the liquid displaced by the submerged portion of the body. Here the entire body is immersed inside the liquid. So volume of the body, it's given. Volume is 100 centimeter cube. That is 100 into 10 raised to minus 6 meter cube. What about density of the liquid? In fact, density of the liquid is water. Here the liquid is water. So density of water is 10 raised to 3. The value of small g is 10 in SI. So 10 raised to 4, 5, 6. So what do we get? 1 Newton. Clear, students? So this is the answer of the second part. Upthrust. The net upward force exerted by the liquid on the body is found to be 1 Newton. Now third one. The apparent weight. The apparent weight of the body. Now look at this situation, students. This is W1. This is the weight of the body in air. Now when it is immersed in a liquid, in this case water, then the liquid, as we have discussed in the theoretical portion, the liquid will exert on the body an upward force, which is known as upthrust. This is also known as the buoyant force. It can be denoted by FB, buoyant force or upthrust. So these are the two forces acting on this body. Its actual weight acting downwards, the upthrust, upward force exerted by the liquid on the body in the upward direction, that is represented by capital letter U or FB. So W2 is the apparent weight of this body in liquid. Obviously, from the diagram it's pretty clear. When a body is immersed in a liquid, then it loses in weight. Its weight, its apparent weight of the body in liquid is less than the weight of the body in air. So here, these two forces are acting in the opposite direction. So resultant would be given by the difference in the magnitude of these two forces, right? So W2 would be given by W1 minus U. Clear, students? So what do we get? W1 is acting downward, upthrust is acting upward. So the apparent weight would be W1 minus U and in the downward direction. So what is the weight W1 of the body in air? That is 7.8 Newton. Minus what is the upthrust? It is 1 Newton. So what is the weight of the body when it is immersed completely inside the liquid, which in this case is water? It will be 6.8 Newton. So what we have concluded in the last question is, students, that whenever a body is immersed in a liquid, then it loses in weight. and the loss in weight of the body is equal to the upthrust, and that is known as Archimedes' principle, which we will discuss in detail in the next lecture. Right? So I hope you have understood this concept. This was a very interesting question. So in order to find out the apparent weight of a body, this is the formula. The actual weight of the body, which is the weight of the body in air, minus the upthrust. Why we have subtracted these two? Because they are acting in the opposite direction. In case they act in the same direction, then the vectors get added up. In case they oppose each other, then the resultant is given by the difference in the magnitude of these two. So that is what I have done. So weight of the body in air is 7.8 Newton, upthrust is 1 Newton. So the weight of the body when it is immersed in the liquid would get reduced to 6.8 Newton. Right? So I hope you have understood this concept of upthrust and buoyancy. So do join me in my next lecture for that very interesting topic of Archimedes' principle. Till then, goodbye and do take very good care of yourself. Right? Stay blessed. Thank you.